Hello, everyone, and welcome to the 13th episode of the StackToHeap podcast. In this episode, we have with us Gaurav Agarwal, who is running his own consulting firm. And today he's going to talk to us about what is GitOps essentially. I think GitOps is a concept that has been making a lot of strides in the last couple of years, and with also the whole ecosystem around Kubernetes exploding as well, I think GitOps is also growing in popularity along with it. So we want to talk about what GitOps is, how it differs from whatever continuous delivery or continuous deployment practices that we have been doing, and where we see it going ahead in the future. Hey, welcome Gaurav. Would you like to introduce yourself first?
Hey Manoj, good evening. Thanks for having me. Hey, like Manoj said, my name is Gaurav. I've been running this company called Agarwal Consulting for the past couple of years. I used to work along with Manoj at Hotworks. After that, shifted to BrowStack and then Circa Labs. Um, Pretty much, I work predominantly on Go these days, but I've worked with different stacks across different layers. Worked on backend, front end, mobile. So I'm pretty comfortable with that. And one of the things which I specialize in is also towards automation and infrastructure. So GitOps is one thing which I've been looking at. I've been adopting very closely in the past projects which I've been working on. So I'm happy to be here.
Welcome Gaurav, and I think very interested to hear about your journey with Agarwal Consulting as well. Maybe that can be a future episode that we can do. So
Sure, definitely.
yeah, coming to today's topic, right? So what is GitOps, and what does it mean to you when someone says GitOps?
So the idea of GitOps predominantly is that you want to have everything related to. Okay, so let me come to it. Let me describe a scenario which I've faced in my projects before earlier, which was whenever we used to do deployments, right? We'll come across these scenarios that you have some scripts in the production system itself, which will run along when you're doing the deployment to the production app. So this would usually not be version control. This would usually not be um, revisioned. So you'd have changes based on each deployment done into the script before the deployment happens within the production environment itself. Um, so now that we have these Kubernetes-based deployments, the philosophy of Phoenix servers coming in where we don't tend to even SSH into our production system, the problem kind of gets simplified in a way where we don't have these scripts managed to do a deployment of a new version of the service onto our servers itself. So that's where GitOps steps in. So with GitOps, we have everything that we need in order to deploy application in production along with the source code of the service itself. So imagine if you have a bunch of microservices, microservice A, B, C. So with each microservice, all the steps, all the scripts, all the configuration which you need in order to deploy that service properly will be along with the repository itself. The idea then is that with your CI/CD server, when you do a git push onto specific branches, you can map those specific branches onto environments and then have the code deployed onto the right environment based on just git commands like git merge and git push, for example.
Okay, so I'm also hearing from someone who is not used to GitOps, right? It's putting everything in code and versioning it in Git, and then using that to do deployments. Right? I'm seeing a lot of overlap with what we generally call as infrastructure as code, what we do with Terraform, Packer, and so on, right?
Totally. Yep.
So to delineate these two aspects, right? What would you say is the major difference between something like Terraform Packer, doing infrastructure as code as a practice for your continuous delivery, right? So how is GitOps
Um,
different from them?
so GitOps is more of culmination of all these different tools itself. You don't tend to see them as auxiliary, rather you tend to then see these services, see Terraform especially as a complementary service to GitOps itself. So with Terraform, which is a infrastructure provisioning tool, you tend to script, you tend to use the HCL, the HashiCorp
Yeah.
programming language to describe your infrastructure itself. So that can be across probably AWS, DigitalOcean, or many other cloud providers, or even your own configuration or own server-based settings can be described using Terraform. So now Terraform gave you that power to describe your infrastructure, but now you still have the question of where do you run those Terraform scripts? Whether do you run from your own system, or whether do you run from a CI/CD system, or whether do you run directly on the servers, some of the production nodes itself, right? So GitOps more as a philosophy comes in where it says that hey, um, you don't want to deploy onto production by running a specific script, or you don't want to change infrastructure by running a specific script on the dev machine. So this can lead to problems because each developer's machine can have slightly different configurations. You could have some of the keys missing. You could have some of the scripts not being running in order, for example, and it can wreak all kinds of havoc into your production or your different environments that you have. So with GitOps, the idea is that you not only code the infrastructure you need, but you also code in. Um, to be frank, you would have a hodgepodge of YAML files as well as Bash scripts, even if you're deploying, even if you're implementing GitOps from scratch, especially. So with GitOps, the idea is that you have all these scripts and YAML files and any other infrastructure provisioning tool to play well together. That whenever you do a Git push, um, your entire infrastructure and your services will change based on what you just push into Git. So GitOps comes in like two different flavors. You can have either pull-based deployment or a push-based deployment. Essentially, the difference being that when you do a pull, let me talk about the push-based deployment first. So generally, when we, especially in since 2010 to 2020, we have been building applications with some CI/CD system in place. The CI system basically runs test cases which are defined in the source code along with the source code itself, and then deploys the code. Right. So this deployment can be even based on some triggers, external triggers, like you press a button and then the code gets deployed. Or you can take it to an extreme where whenever some code change, whenever the test cases pass, you push the code onto the production server itself. So that's what GitOps talks about as well. So from your CI system, CI/CD system, you not only set up your server, you not only run your test cases and validate whether your code works, you also build the binaries or the artifacts that you need for deployment, and then ship them onto the production server, as well as provision the infrastructure you need in order to make service working.
Okay, so to just to understand a bit, right, so if I'm already doing a lot of this, say So obviously, code is in repo, and say Terraform is in repo, obviously, and even my CI/CD pipeline configuration as say YAML that a lot of servers are supporting right now, right, is in code. And then I've set up pipelines which then build and some set of tests and then deploy them to an environment, where an environment could be an existing Kubernetes cluster or say provisioning some machines using Terraform, Packer, and so on.
Mhm.
If I already have all this set up, am I already doing GitOps? Would that be a fair statement?
Okay. One counter question to this. So if you have all this set up, in order to get your code, the code changes which you just made, to get to production, is all that you need to do is a git push? If the answer to that question is yes, then yes, you are pretty much doing GitOps.
Okay, because a lot of the setups that I've seen, at least, and I'm currently involved with also, like is doing continuous delivery with a very similar flow, and everything is maintained in Git. Maybe there are parts of it that are not in Git, like for example, we use GoCD, and not
Mm-hmm.
every pipeline that is there in GoCD is in version control because of how GoCD itself has evolved, because that wasn't featured before,
Yep, yep, yep,
right?
yep.
So what I'm hearing is it's like following everything in code or everything version as a very strict philosophy to follow, and then making sure we are following it and making source code or the Git repository as a single source of truth.
I mean, so you can think of it this way: like the challenges which we solved with those pipelines, right, was
Mm.
the problem that we as humans we tend to make mistakes. We tended to forget one of the steps while we are deploying to production, and we see that if one of the most common steps which are forgotten is that assets compilation, which would happen. We might not be shipping them to the CDN, and the users may find it that the initial load of the app could be slower just because the assets are not dispatched to the CDN, for example. And this was very common. These are like some of the auxiliary steps which we don't think of when we are deploying to production, especially if we have a critical bug fix, which is or a security release which is going into production. We might miss out those steps. What GitOps, or rather the CI/CD itself, kind of came in and said that hey, you codify all of this in a way that any developer who has to deploy to production will automatically trigger all these steps. They don't even have to think about it. So it's kind of like moving from one-click deployment, the idea of one-click deployment, and making that click translated to git push. It's as simple as that. Now with Kubernetes and clusters, the alternate idea with deployment was, unlike push-based deployment, where a push basically means that the CI server or the CD server, which is not exactly part of your infrastructure, which is not part of your production setup, is the one which is responsible for setting up the production server. You can have an alternative where you can have a pull-based deployment as well, where um, your CI server is responsible only for triggering the test, whereas you can have a pull-based deployment where the production cluster itself can detect any change. Like for example, if you have Kubernetes-based deployments, then you'll be relying on Docker containers. So you can um, check for any push to the repository and push to either the Docker repository or even to the source code to check if to sense if there are changes, and then within the cluster itself, you trigger a process which updates the service.
I think that distinction that you talked about, like making the one-click deployments, which will then take it to production all the way to production, right? And replacing that with Git commit equivalent. I think that makes a lot of sense to understand what GitOps means. But that also raises a question that I want to ask is, if every Git commit is meant to go to production, then which means we are essentially following continuous deployment, right? But what
Yes.
if I wanted to do continuous delivery, where I think the main primary distinction is we want to make every commit available for deployment, but not necessarily deploy them. Right. So, is that even an approach that people follow with GitOps? And if they do, how do they even do it?
Okay, so there is kind of like a catch over there with the commit um, with continuous or continuous delivery itself, right? Where the way you define a commit itself can be different. One is when you merge a PR onto a certain branch. Let's say you had if you're following the Git branching model, you'll have a master branch which pretty much mirrors the production, and you'd have the dev branch, or you'll have feature branches which would be merged into the master or production branch itself, right? So if you have a model like that, a commit then would be defined as the merge commit itself. So in a way, each commit which you make onto the production branch would in turn actually cause a deployment. So you are doing continuous delivery with the GitOps approach. The one thing though, where GitOps would differ from continuous delivery would be you don't necessarily deploy each progress on the feature. You deliberately create PRs, and after reviews, when the PRs merge, especially for, with the approach which I'm currently following with my team right now, is that we ensure that master tracks to production environment, develop tracks to develop environment, staging, and sandbox are the four environments which we have. So each of these have their own Git branches. So these branches mirror the source, mirror the environments 1:1. Like they are responsible for maintaining the environment 1:1. The CI system which we are using is basically a Circle CI. It's nothing fancy. But with Circle CI, what we are trying to achieve is that so with Circle CI, you have all the pipeline information also built into the source code itself. So Circle CI uses this config.yaml. I'm not sure if you're familiar with it. So that's one place where it differs from GoCD. So with Circle CI, we can also say that, hey, for some of these branches, other than, let's say, masters, the 4 branches which track the environment, for the other branches, don't run the deployment steps, just run the test cases. So if you strictly would follow continuous delivery, you'd actually have every commit in your version control system deployed onto production, whereas we don't tend to do that. We tend to restrict it by following the review process, where each time you complete work on a feature, you create a PR against, you actually test it out on sandbox environment. That is, you just do a force push on the sandbox environment, and the sandbox environment updates to whatever changes you need. And you can test out your code over there as a developer. And then as an individual, you can test your code over there. But then later, when you want the entire team to get involved, you can create a PR against the develop branch. The develop branch is where we sort of like, this is more of a controlled deployment. We don't want every commit to go towards master itself. So we want to test out stuff in develop as a team, review it as a team in develop itself, and then from there it gets promoted to higher environments like staging, which is for it can also be called as a UAT environment, user acceptance testing environment. And then we release it to prod by creating a final merge commit from staging to production to master branch.
Okay, so to understand it a bit more, so we would say for when we are creating a feature, we would have a develop branch, and then when we are ready to deploy that to say a QA environment, we'll merge it into a QA branch in the say. Would that
So
be an
from
approach?
develop branch, you take a cut and create your feature branch. That's the approach which I've been following in my team.
Okay.
You can have your own flavor though. It's very well valid that you can do feature developments on develop branch itself and then merge it onto QA and then probably then deploy it to production. And you can have any sort of um, approach towards this. With GitOps, you don't necessarily have to um, stick to having 4 different environments. You can have whatever setup makes sense to you. But the final idea is that with production, you have any deployment to production always happens only through git push. It does not happen through um, any script which a developer runs on their machine, essentially.
Okay, got it. So one question that I had when we were talking about everything being in Git, right? So what are the security implications and how are secrets handled in this scenario?
Totally. So yeah, this applies both to push and pull based deployments. With GitOps, the idea of secrets is you still don't manage secrets. We, as developers, we don't want secrets to be part of our source code, especially that you don't want every individual team member who has access to this code base to have production service access. So these can be sensitive secrets like AWS access keys, secrets, and all that, right? The idea there is that you don't check in your secrets still. You still use some third-party services like perhaps Vault, perhaps so you can even use something like Circle CI's context, for example, to inject those secrets at deployment time. If you're doing a push-based deployment, whereas for a pull-based deployment, you can of course either pull the secrets from AWS key management store or even Vault, even HashiCorp's Vault works there, for example. So yeah, you still keep secrets away from the system. So that's the one place which actually requires manual updating of secrets by the developer itself. But yeah, I mean, that's the only place we can't really automate. Or we rather do not want to automate because of the implications it has. The problem though, so since we are on the topic of security, since we are on the topic of secrets, so the problem which can happen with push versus pull based deployments is how you inject the secrets is different. So with push based deployments, you can have your CI system inject the secrets into your code. You can even replace some of the places where you're using the secrets with the actual. You can have a placeholder which can be replaced with the actual secret itself. You can, with the pull based deployment though, you don't tend to replace anything. Rather, you pull in the secrets at runtime. You with Kubernetes secrets, the secrets deployment type, the secrets object type in Kubernetes, you can have secrets which can be updated in Kubernetes itself. Though of course it does not restart the services, you still would have to update the secrets and do your deployment. So one of the tools which comes in handy, especially with pull-based deployments, is Argo. I have not personally worked extensively with Argo, but Argo is one tool definitely which comes in handy. So this allows you to create pipelines which run on your Kubernetes cluster itself. So with pull-based deployments, the idea is that you have your CI/CD pipeline not running as an external service, but rather running it's something which is running on your cluster itself.
Okay, got it. So what I'm hearing is that while both push and pull-based mechanisms exist within the realm of GitOps, the pull-based method is probably a bit more secure, especially when handling secrets and so on, right?
Not necessarily. So okay, so the thing is, so if we are talking about vulnerability, with Git, with the push-based deployment, your CI system itself becomes your um, vector of attack. It falls under the vector of attack. Your CI system, when you have it running within your cluster becomes invaluable. Any attacker which has any access to the cluster would probably have access to enough to do enough damage to your environment itself. So that's one thing which I have noticed as well. So especially this can be with since we talked about Terraform, right? So Terraform does require AWS secrets. Um, like for example, if you're provisioning something on AWS, you'd require AWS secrets, which has the right sort of access to provision, let's say your database, to provision servers, to provision clusters, and all that. So that particular secret which you have, which you're injecting during a push-based deployment, can probably not have enough access or will not need enough access to do all those changes, like to provision a RDS instance, for example. Whereas with the pull-based deployment, the AWS secret, which would be required within your cluster, would have much more privileged access, would have much more um, access to your infrastructure itself. Is one thing which I've noticed. So yeah, so there are definitely trade-offs with both.
Okay.
It
So my reasoning for saying that is because if you run Terraform apply from a developer environment, right? So
Mhm.
the say it's for a particular project, but a developer box, the credentials that might be set up on a local dev box might, with say a user credential, might in most cases be having a bigger a set of permissions than what is needed for that particular Terraform apply.
Right.
But what I was thinking when you said Git apply, a Git pull mechanism is where something is happening from within the environment,
The
right?
cluster. Yep.
Whatever the app is going to need, whatever the app is supposed to access, only that access is already going to be set up within the cluster, right? So that is where I was coming at from. So when you said like the pull mechanism is going to be within the cluster, I was thinking like access to secrets, access to the right permissions. Even if you think
Mhm.
about in Kubernetes side, right, the RBAC configurations and such, right, they will be uh, to the right level that the app is going to require, because that is what the app is also going to access. So that's where I was
So
coming at it from.
so yeah. So in that way, if you're only thinking of at the app level, the same thing applies to both push and pull. But when you think of at the infrastructure level, especially with Terraform apply, right?
Mm-hmm.
With both GitOps, with both push and pull models, you don't want to do the Terraform apply anywhere in your machine, in your dev machines. Rather, the Terraform apply moves to some other server. The question is, where does it move to? With push-based operation, with push-based deployments, you tend to have your Terraform apply happen on the CI server. So CI server would have a privileged access to the infrastructure itself. So this can allow the CI server to create or destroy whatever resources it needs in order to run your service.
Mm-hmm.
Whereas with a pull-based deployment, the cluster itself can have elevated access because the cluster itself is responsible for making changes to the infrastructure. This also brings into the question of the bootstrap problem, right? How does the initial um, pull-based deployment happen then? So the initial pull-based deployment is usually manual setup. You do have to set up the infrastructure to a level which can then do your following pull-based deployment.
Got it.
But then the idea is still that the cluster itself will have privileged access to your infrastructure, which generally does not bode well.
Okay, so you mentioned Argo, and I think a previous episode that I did was discussion on the ThoughtWorks Tech Radar. As an ex-developer, you should you're also familiar with it, right? So Argo is one of the tools that is there on the current Tech Radar as well. So what other tool would you say is very popular in the GitOps space. How is the tooling around GitOps evolving right now?
I mean, since everyone's moving to Kubernetes, Argo does make sense, especially it works well with Kubernetes. Any other tools I can think of? I mean, the other infrastructure, any other tool which can allow you to configure your entire infrastructure, your stack declaratively is valuable. So Terraform comes into the picture. Kubernetes YAML files, of course, helps. Um, what else does come in handy?
And there is Flux as well, right? So I think.
So Flux CD is sort of similar to Argo itself in a way. So it actually ensures that the state of your Kubernetes cluster is the same as the one which you have declared in your CD pipeline in your source code itself. So it uses so it's the same GitOps principles which are being followed here. Flux does have an operator which is deployed within your Kubernetes cluster. So it 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 is more closer to the pull-based deployment mechanism than the push-based deployment mechanism in that way.
All right. Since you have been following GitOps, what would you say are some of the biggest challenges with following it, or at least being very close to the philosophy of GitOps, right? So, what did you find as the major challenges?
One of things apart from initial setup, I would say is the familiarity of the team with the infrastructure itself. So with GitOps, since it simplifies infrastructure to a extreme level that the only thing the other developers in your team require to deploy is a git push. The familiarity with the underlying infrastructure becomes constrained. This can be at a team level. This can differ team to team, but this is what I've seen. This is something which I've tried to solve even through lunch and learn sessions where I would walk them through the infrastructure, but it does become very unwieldy. So even though we have GitOps, right, we do tend to use a lot of glue code like YAML and bash scripts in order to make the entire infrastructure work. You do need bash scripts at some point of time to even run the Terraform apply, right? So that's one place that's the one major pain point I would say is of GitOps. The other things, I think it's also a plus in a way because it simplifies infrastructure so much that the other team members don't even have to think about it. But this is something which you'd have to solve at a team by team level, on a team by team basis. Yeah, that's pretty much the only drawback I can see of it.
Sure. With what you have experienced, with what you are seeing with how the tooling is evolving, how the Kubernetes ecosystem is also exploding, right? So where do you see GitOps, say 1 year down the line, 5 years down the line? Do you think everyone is going to move towards it, or it's going to be just few set of folks in few set of scenarios trying to implement it? Where do you see GitOps going?
I mean, all of us are doing some sort of push-based deployment at some point, right? We do have all our infrastructure as a code. We have our service definitions, our replicas, all indicated within Kubernetes YAML files. So in a way, we all are at some level closer to GitOps than we think. We are probably a few steps away at most. But the thing which I see though is the pull-based deployments. So this is something which I'm looking into the crystal ball. Personally, I feel pull-based deployments are more complex than push-based deployments, especially given that you don't have a separate CI/CD server responsible for setting up your application. Whereas with pull-based deployments, you have everything. You have to do some manual setup in order to get your clusters up, and then which can do the further deployments within the cluster itself. So you have the bootstrap problem. You do have the problem also of the fact that with push-based deployment, you can have your CI/CD server isolated. You can actually have it be responsible for managing your secrets, for injecting your secrets, right? It does increase the attack vector. You do end up paying for it as well. So with pull-based deployment, you don't have a separate CI/CD server. So everything is within the cluster. You are already paying for it, and you use the unutilized resources of your server to deploy the latest version of the server, to build the artifacts and deploy the latest version of the services that you're running on Git. So in a way, yes, I would see more people adopting push-based deployments than pull-based deployments. It does take a lot of knowledge of Kubernetes itself, a lot of knowledge on the operators itself in order to deploy, in order to have a pull-based deployment. And the advantages of it are not many, in my opinion. At least I don't see many advantages with a pull-based deployment.
Okay, got it. Thanks, Gaurav. I think those are all the things that I wanted to ask from you. I think as the tooling matures also and it gets popularity, I think we'll also like to talk about one of the tools in detail, maybe in a future episode, based on how your experience has been, and also to see if I have tried something in the meantime. So I
Sure,
think, but this
definitely.
covers at a high level what GitOps is, or at least to understand when people say GitOps, what are they talking about, and what is the general understanding about it in the industry. So I think you pretty much addressed that part. Any other
So
closing comments from you?
yeah, I think one of the other tools which I completely skipped talking about was Helm. Helm actually comes in very handy, especially when you're doing Git-based deployments. You have your Helm charts, which are in a public repository, in a Helm repository, which you can deploy to your cluster. So, yeah, that's one thing which I sort of missed talking about. But yeah, that's pretty much it, I guess. Thanks once again for having me, Manoj.
Sure. Thanks a lot, Gaurav. Thanks for taking the time. Yeah. Bye.
Bye-bye.